Good afternoon, class. So in today's video, what I thought I'd do is I would demonstrate the gas law of Boyle's law. So in this one, it's going to be pressure 1 times volume 1 is equal to pressure 2 volume 2, which is good. Basically saying if I take something like this syringe, and if I increase the pressure, the volume will change because they're inversely related to each other. So because pressure and volume are in this law are inversely related, so as one goes up, the other goes down. Here's my question to the class. Let's say I took this syringe, right? And if I just squeeze it like this, nothing happens, air gets pushed out and all of that. What would happen though if I covered this? If I capped this with my finger like this, and I continued to pull this down and increase the volume? Yes?
Your finger would keep the skin on your finger would suck down into the syringe.
Okay, so there'd be my finger would get sucked into the syringe. That's true. What else would happen? What would happen to the air pressure inside of this syringe? It would what? It would increase if I increase the volume, the pressure will increase. Oh no, what would it be? Oh, it would decrease. Okay, very good. So what you're saying is that if I pull this like this, the air pressure is now lower inside, right? So if I were to do that, what would you expect to happen when I let go? It doesn't have to be you, it could be anybody, but what do you think would happen if I let go of this thing? Would it stay where it is, move further, or would it go back in, stay where it is, or move further out? Stay where it is? Okay, sounds good. Good prediction. Anybody else got a prediction? All right, if not, let's find out what happens. So first I'm going to pull this out, pull this plunger down, and then let's see what happens when I let go. What happened? It went back up. But why is that? What caused that? Actually, what was doing the pushing in that case? Was it the gas, the air inside of here that was at lower pressure? You know, and you might think that it could be pulling it because of that, but actually it's because the air outside has a certain pressure, right? Which we would call 1 atmosphere. The air in here right now is also at 1 atmosphere. However, when I cap this and I fix the volume inside of this syringe, when I pull this back, it's actually less than 1 atmosphere inside of the syringe right now. So that means there's a pressure differential between the inside and the outside. What does that mean? That means there's going to be an extra force that would force this back up, like so. Okay, so again, pull it down, let go, and it comes right back up. What if I went the opposite way? What if I said I'm going to push this in a little bit while keeping my finger here? What happens? Well, if I let go, what's going to happen to the syringe? It'll go back down. Let's find out. Maybe that was not so good. Let's do that again for the camera. And did you see it went down? So it did go up because the pressure was increased. So because there was a greater than 1 atmosphere pressure in here and only 1 atmosphere pressure out here, it would push the syringe back down. Otherwise, what might form is a vacuum, and nature does not like to deal with vacuums very well. So shout out to period 7, school year 2023 to 2024, and hope that kind of made sense as a demonstration of Boyle's law. So study hard. I'll see you guys in the next video.